Hi, Algebra 2. This is Unit 4, Lesson 10, and today we're going to talk about logarithm laws. And they are related to the exponential laws that you already know. So if I'm looking here, the product property, remember when I have two exponents with the same base, I'm going to add those exponents together. So b to the m times b to the y is equal to b to the m plus y. Well, exponents and logs are related. If I have log base b of m times n, I can separate them and make it log base b of m plus log base b of n. Okay, so let's look at a few examples right here. So here I have two logs. I am adding them together, so I can make it log base 2 of 7 times 4. Okay, so basically I'm doing the opposite of what I had over here. Just remember that if I have log base b of two things that I'm multiplying, I can separate them and I can add the two separate logs together. Or if I have the two logs separated already, I can just combine them with multiplication. And this is log base 2 of 28. If I have log of 25 plus log of 4, if I don't have a base, remember that's base 10. So that's just equal to log of 25 times 4, which is log of 100. Okay, so I can work, depending on what I need, I can either combine them into multiplication, or if I have multiplication, I can separate it into addition. So this is going to be log base 4 of 2x times 4x squared, which is log base 4 of 8x cubed. And then down here, number 5, I did skip 3, 4, and 6. But number 5, there's multiple answers that I can use, but I can make this log base 7 of, say, just two numbers that multiply to 45, say 9 times 5, and then I can write them as two separate. Log base 7 of 9 plus log base 7 of 5. Okay, remember our quotient property. When I'm dividing, I take those exponents and I subtract them. Okay. And if I have logs that I am dividing, log base b of m divided by n, I can separate those into two logs that I am subtracting. So if I have log base 3 of 24 minus log base 3 of 8, I can combine them into one log of division. And 24 divided by 8 is log base 3 of 3. I skip number 8. Number 9, again, I have subtraction, so I will combine them into one log, and I will divide those. So x to the 9th divided by x squared, which is just x to the 7th. And then I can also expand these. So there are multiple answers that would work right here, but log base 8 of 4. So I can make that log base 8 of, say, something that equals 4, 8 over 2, and then I can just separate those, and I would be subtracting them. So I'm expanding right down here. Log base 5 of 1 minus log base 5 of 3. I also could have used numbers that also equaled 1/3, like 15 over 45 or something like that. And this would just be log base m minus, log of m minus log of 7. This would be a base 10 because no base was written. All right, power property. So this is going over our exponential properties also. When I have a power to a power, that would just equal b to the x times y. And when I have a log base b of m to the n, that n is going to come out in front. Log base b of m. Okay, so look what happened to the n. It moved out to the front of the log. This we're going to be using a lot when we're solving. So 5 times 4, log base 4 of 2. I'm going to take that 5 and I'm going to move it back to the exponent. So it's going to be log base 4 of 2 to the 5th. And 2 to the 5th is just 32. Okay, so I'm taking the number in front and I'm putting it back into the exponent. Log base 2 of x to the 7th. The number in front is going to go back. This is base 10, so log base 8 to the 1/3. Okay, or we know that 1/3 is the same thing as the cubed root of 8 as well. Now I'm going to take the exponents and I'm going to put them out in front. So 7 times log base 2 of 8. So we should be comfortable working both ways. Again, this x minus 1 is an exponent, okay, and it's going to move in the front. So 3 times x minus 1 times log of 4. So that's 3x minus 3. And when I have multiplication, I am subtracting log of 4. Wait, let me just fix that. I'm not multiplying two separate logs, so it's 3x minus 3 log of 4. My mistake. Okay, and log base 7 of the square root of w, that's log base 7 of w to the 1/2, and that 1/2 can just come out in front. 1/2 log base 7 of w. And I can condense logs. So this 2 that's in front, I'm going to put that back as an exponent, log of 6 squared. And when I'm subtracting, I divide. So this is going to be divided by 9. So that's really just log of 36 divided by 9, which is log of 4. Okay, so I'm taking my exponent rule, and I'm also taking the fact that I'm subtracting these, and I'm going to put them back together as division. Again, this exponent is going to go back up as an exponent. That 4 in front is going to go back up as an exponent. So log base 4 of a to the 4th. And plus, and again, this 2 in front is going to go back as an exponent. Log base 4 of b squared. And I am adding these together. So I will, and they have the same base. So remember, I can join them together through multiplication. Log base 4 of a to the 4th b squared. All right, so lots of rules, just lots of practice. We'll practice some more with these tomorrow as well. So here we have number 21. Remember, a number out in front is really just the exponent. So I'm going to put that back as the exponent, and this 3 is going to be the exponent over there. So this is going to be log base 4 of a to the 7th minus log base 4 of b to the 6th, because there's already a 2 and that 3 is becoming an exponent. So 2 times 3 is 6. And then when I have subtraction, as long as I have the same base there, I'm going to combine that together. So that's log base 4 of a to the 7th over b to the 6th. I'll combine them together since they have the same base, and I'll combine them and they will be dividing now. Log base 2 of 15 times 4. These have the same bases, all right, and I am adding them, so I'm going to combine them through multiplication. And then this also has the same base, but it's subtraction. So for that one, I will divide. 15 times 4 is 60. 60 divided by 6 is 10. And I keep that same base. Okay, so again, all of the next ones, they all have that same base. So I'm going to take the addition and I will combine those in multiplication. And this 1/2 is going to go back up here as an exponent. So it's going to be 49 to the 1/2 times 49 to the 1/2. And 49 to the 1/2 is actually just equal to the square root of 49, which is 7. So this whole thing right here actually just equals 7. And this right there, 4 times y times 7 is just 28y. So let me just write the whole answer. Log base 3 of 28y. You can see that these are getting a little bit complicated here. The 3 is going to go back up as an exponent. Log base 2 of 4 to the 3rd. there is subtraction here, and they have the same base, so I'm going to combine those together. And when I combine them, it's going to be division is how they're going to be combined. 4 to the third is really 64. 64 divided by 32 is 2. All right, so there's a lot I can do with these. 25 right here, I want to expand these. So this is all multiplication, so I'm going to separate them. Log base 6 of x plus log base 6 of y. There's multiplication, but when I separate them, I'm now adding them together. And that's z to the fourth, so the 4 is going to come out in front, and it's going to be log base 6 of z. So I took something that was already combined together, and I expanded it. When I have division on 26, when I expand it, it's going to be subtraction. So log base 4 of a to the ninth minus log base 4 of b, and then that 9 can come out in front. 9 times log base 4 of a minus log base 4 of b. Okay, so I'm expanding them here. And this 2 is an exponent. It's going to come out in front. And then log base 7 of q to the fourth plus log base 7 of r squared. But then this is an exponent that's going to come out in front. So it's going to be 4 times log base 7 of q plus, and then this exponent, this 2, will come out in front. 2 times log base 7 of r. And then when I multiply that, I would have 8 log base 7 of q plus 4 log base 7 of r, because I'm distributing that 2 to everything inside. So that was a tougher one. All right, let's look at some multiple choice. I did skip 28, and then down here I skipped 31. And I can see that some of my signs here sort of disappeared. So let's put those back in. This was a plus, this is fine, this is a plus, and this is a plus. And this was log base 3 of just 9x. These were parentheses here. Okay, so I want to know which of the following is equal. When I have multiplication, I'm going to separate it with addition. So log base 3 of 9 plus log base 3 of x. Okay, so basically this is saying 3 to what exponent equals 9? Well, that's 2. 2 plus log base 3 of x. I'm just trying to simplify, move things around till I get something that is similar to one of my answers, and I finally did. All right, and 30, if f of x equals log of x and g of x equals 100x to the third, then f of g of x. So basically, I'm going to do what's in the parentheses first. I'm going to do the g of x. So the g of x is log base 100, well, it's going to be base 10, log of 100x to the third. Okay, and then I'm going to separate that. I'm going to make it log of 100 plus log of x to the third. Okay, and log of 100, that's base 10. So basically that's saying log base 10 of 100, that's equal to 2. I'm going to take this 3 and move it out in front. 3 log of x. Okay, and there I go. Choice 4. And I just have a little summary on the next page. So basic logarithm rules. If I have log base b of b, that equals 1. Because remember, log is just the opposite of an exponent. This is really saying b to the first power equals b. And log base b of 1 equals 0. Again, b to the 0 power equals 1. An example, if I want to simplify, log base 14 of 14 just equals 1. Log base 3 of 1 equals 0. Anything that has, any base, doesn't care. I don't care if it's log base 3, log base 4. If it's of 1, then my answer is 0. The product rule, log base b of m times n, is the log base b of m plus the log base b of n. So I separate them and I add them. When I have division, I separate them and I subtract them. And look at some examples here. So if I'm adding them together, as long as those bases are the same, I can take them and I can combine them with multiplication. And obviously I would just write that as log base b of 42. Okay, if I wanted to expand it, I would just think of two things that equal 63, like maybe 7 times 9, and then I can separate them. When I separate them, they're going to be adding them together. Okay, and when I'm condensing them and I have subtraction, I'm bringing them together, I am going to just divide those. And 84 divided by 12 is 7. And when I expand it, I'm just looking for something that equals 9. So I could say log of 81 over 9. And then when I expand it, that's division, so I will subtract them. And the power rule is basically that exponent comes out in front. That one we will use. Oops, this is a B and this is an M. So if I have this right here, 2 times log base 3 of 8, that's really log base 3 of 8 squared. That 2 goes back into the exponent, and 8 squared is 64. So log base 3 of 64. Or I could take that exponent and I can write it in front. So this says x minus 1. So it could be x minus 1 times log base 2 of 6. Okay, and change of base formula. So that one we did previously. So log base b of 8 is just log of a divided by log of b. So if I have log base, what is that, a 7 of 32, I say log of 32 divided by log of 7. And I could do that in my calculator, okay? And you actually get an answer. So base 10s are the